Welcome to the video, and in this video we built an 8-foot Eiffel Tower. Now let me show you how we built it. In this model there are 3 main sections, and the first one is the base. Now the base is made mainly out of 4 pillars, so I'll get started on the first one. So now that I have the first leg done, all I have to do is build 3 more of these. Now that I have all 4 built, it's time to build some braces and the land that goes underneath it. So now that we have that all connected, I'm going to build a support structure that goes around the edge to give it a little bit more strength. So now that we have the base done, we can build the middle section and put that right on top. So now that I have the middle part done, all I need to do is put it on. So now that we have that done, it's time to build the last section, which is also the tallest one. Now that we have that done, we need to put it on, and we did move it to the corner so that we could get this shot. And time to put it on. And there we have it. Now we didn't actually design this model, so I'm going to show you where we got the design from. Now, if you go to lego.com and scroll to the bottom, click on support, find building instructions, it will bring you to this page. Now from this page, you can download a PDF form of every Lego set instruction that Lego has ever made. So for us, we went to Lego Creator Expert, and oh, there it is, Eiffel Tower. View that, and we have 3 PDFs for the 3 different book pamphlets. Now I'll click on the first one, and it will download a PDF form of the Lego instructions. Now for all Lego instructions, you just scroll down and follow the instructions step by step. By the end of it, you get the full model. So what we did was we followed these instructions and built this Eiffel Tower. But you'll notice, if I scroll down a bit, the scale of this isn't actually the scale of this model. And I'll explain what that is. This model is 4 feet tall. If I scroll to the top, yes, right here, in kind of low resolution, it's actually 108 centimeters, which comes out to about 4 feet. But this model is 8 feet tall. So why is that? Well, what we did was we used the instructions and times it by 2. So So now I'll explain what timesing by 2 is. This is a 1 by 1, and this is a times 2 1 by 1. Now what does that mean? Well, this brick right here has a width of 1 dot, or 1 brick, a depth of 1 brick, and a height of 1 brick. So it is a 1 by 1 by 1, technically. And this is a 2 by 2 dots by 1 brick tall. Now, in order to make this, we had to take any brick, so for example, a 1 by 1, times it by 2. So we took 1 brick, made it 2 bricks, 1 brick deep, 2 bricks deep, and then 1 brick tall, 2 bricks tall, which explains the 8 feet. And that's how easy it is to times something by 2. Not really. It's actually very hard to do that. Why? For some bricks, it's not that easy to times it by 2. For example, slants. Now, this is a 2 by 3 by 1 slant that is inverted, or upside down as we call it. And this is a times 2 version. And it's not quite that simple as stacking 2 of these on top. What this actually is 1, 2, 3, 4, 5, 6, 7, 8 bricks in total. That's not just 2. So times that by a whole model and you need a lot of bricks, which is why it has so many colors. And the other part of that is that it's not very structural. For example, if I rebuild this in a different way, we can run into some issues. Now with the base of the model, the first layer, there are a whole bunch of upside down slants. And this is actually somewhat what is actually in there. Now, with this and the model, the way it works is a lot of the weight goes onto a couple of these dots right here. So like that and dot. But if we build it in the wrong way, which this brick is, it's actually only held by these under parts. Because underneath, it's held by there. So basically, the weight goes into this, and it's actually only held by 4 dots. But with this, it's just a brick. You could put weight on that part, and then support it from under here, and it's just 1 brick, and it's not gonna move. But with this, it can actually break, and the whole model will tumble down in a giant chaotic mess. So how do we solve this? Well, if you overlap the bricks in a certain way by offsetting it with 1 dot, and then add thinner versions of this that are just 1 dot thick, then they overlap so that the next brick goes on like that, and it actually transfers all the way down the pillar. And that's pretty much what we had to do for the entire model. And on top of that, it's just a lot of weight and a lot of bricks to hold. Now, how much weight is it actually? We don't know, but we do know that it is approximately 8 times the mass of the original build. How do we know that number? Well, if you think about it, the weight of this brick, when it's times by 2, it's actually times by 2 in all 3 directions. So the width is times by 2, so that's twice the weight. And then the depth is times by 2, so that's twice the weight. And then the height is times by 2, so that is twice the weight. So in reality, 2 times 2 times 2, 8 times the mass. And that is a major problem structurally if the model can't support it. And now you know the basics of engineering. Well, I hope you enjoyed the video. If you did, please consider subscribing to our channel and hit that notification bell to see when we upload our next video. And feel free to comment down below how long you think it took us to build this model. And we'll pin you if you're right. And thank you for watching.